Well, in every TPRC Talks, we invite people from around the globe to talk on this topic, relevant partners. And today we have Franco Costa from Autodesk. Hello, Franco.
Hello,
Hi,
Annie.
welcome. Hi. Hello.
Hello, Annie.
You are Research Director for the Autodesk Moldflow product family for the company Autodesk. You're in Melbourne, Australia. It's a bit after midnight for you, so thank you for being with us at this time. Can you tell us a bit more about Autodesk and where you fit in the organization?
Sure, Annie. Well, Autodesk has a broad portfolio of softwares for different engineering purposes. And mostly they're centered around aiding design and aiding users to bring their designs to realization. And this is across a broad range of industries. You might know Autodesk software in the construction industry, media and entertainment industry, but also primarily the area I work is in the product design and manufacturing industries. And in particular, our focus is around design and make. So not just a CAD design package, but also tools built into that to help our users realize the manufacturing processes of their parts. And so, there's milling operation software, there's various other softwares for manufacturing. But the one that I'm focused on is the injection molding simulation software, injection molding and compression molding processes. And this is the Moldflow software, which is now part of Autodesk, has been for many years. So for injection molding simulation, for injection molding simulation, our philosophy of the simulation is to make it accessible, to make the software tool something that's understands the manufacturing process and gives guided results towards the users of our software, and provides the material data necessary for that simulation product. So it's kind of, we're aiming to give a total package there.
Mm-hmm. And related to the Compete project, can you share some learnings with us, the biggest learnings in this?
Sure. Well, coming into the Compete project, what we were looking for was some industry-specific knowledge about composite overmolding processes and the design philosophies behind that. We, because of our injection molding experience, we didn't necessarily know a lot about the composites. So what we've gained is, through this Compete project, is an awareness about the physics, about what's happening in that manufacturing process, the issues of fiber migration that we've already heard about today, issues about the remelting, the importance of considering the ply directions in the designs. These are really important factors that we didn't know about prior to coming into the Compete project, and we've learnt from the project. The other thing that's been useful is the validation case studies that we've been able to use to demonstrate that some of the assumptions that we've made in our simulation of composites overmolding are valid and that we're heading in the right direction.
Thank you. You already shared some benefit you had from this collaboration. You're a special partner at TPRC because you're only part of the single project. Can you share some benefits on a company level?
Well, for us, it's been the process, the industry knowledge and the process awareness. What we've really appreciated about the TPRC's experience that it's brought to us is the practical knowledge about the process that we didn't have. And also, of course, the collaboration with the various industry partners means that we've been able to form those relationships, show them what we can do with our software and learn about their needs for the software as well.
Thank you very much. Interesting. Thank you for sharing this story with us. Well, we have Matthijn de Rooij joining this show. He is Professor Service Engineering and Maintenance at the University of Twente. Welcome, Matthijn.
No, thank you.
Hello. And you're
Hello.
also the supervisor of Vanessa, right?
Yeah, one of them. She has multiple supervisors.
Okay.
Also Sebastian.
How proud are you when you hear her talking? How proud are you when you hear her talking?
I'm very proud. I mean, I think she explained things so carefully that, well, what can I say? I think she did it very well so far.
Great.
Yeah, very nice.
Can you tell us more about the Service Engineering and Maintenance Group at the University of Twente and your role within that?
Yeah, let's say services and interfaces are, of course, very important to us, as the name already indicates. It's not just composites, service and interfaces everywhere, and they often need special attention in some way. And we have three types of interfaces we study. Some interfaces are supposed to move, like hinges or bearings, and then you want to often separate them with lubricants or reduce friction, and this is the field of tribology. This is more or less the foundation of the research group. And the other extreme, you have interfaces that should not move, like the ones from Vanessa. They have to stick together. So then you talk about joining, where you want to join services together and to make them more reliable, to understand them better. We've also assisted professor working on that, Jamal Sanyani. And there are also interfaces that are on the edge of moving. Interfaces, for example, in positioning mechanisms, but also in earthquakes, very different, which is actually a sliding phenomena in faults in the earth crust. And they also work together on geologists with University of Utrecht. So it all looks very different, but actually there are lots of similarities. In all cases, you talk about services interacting, and I think you can learn a lot from each other, from all these different fields.
Mm-hmm. And can you tell us a bit more about in which areas you collaborate with TPRC?
Yes, well, of course, hybrid structures with Vanessa, but also before that, we already worked together with Yibo Su on hybrid structures. We also worked together with Lang Yong, who worked on anti-sticking between mold and a composite material. But also soon we'll start another project, not with TPRC, but with Tijin on aerometer ropes, where all kind of fibers interact. And of course, this knowledge can also be used again at TPRC, because interaction between fibers will also be very important for composites in the end. So it goes two ways, I would say.
Nice. Well, when we talk about multi-material joining, how do you look at the future?
Well, it has already been indicated that interfaces are very, very complex. I've already mentioned several times. So I think that the focus should be on making them more reliable and predictable. Let's say properties of materials are known to some extent, but this is not true for interfaces. And you have an interface. If you join materials together, you always have interfaces. So there's not a lot of things known at this moment, and it's really important to understand these interfaces better to make them more reliable and predictable. This, I think, very, very important for the future.
Thank you very much for your contribution, Matthijn.
Yeah, thank you.
Well, talking about partners, we have another special guest from the industry. We have John Grasmeder, Chief Scientist of Victrex. Hello, welcome. You're in the UK.
That's right, Aniek. Hello.
Hello, welcome, John. Victrex is a supplier of peak-based polymer solutions. You got involved at the TPRC within the COMPETE project and now being a full member of the consortium. Can you tell us more about Victrex and your role in the organization?
Yes, of course. So, as you said, Victrex is a world leader in high-performance polymer solutions, and in particular, PEEK and polyarylether ketone-based materials. We focus principally on 5 markets: automotive, aerospace, energy, electronics, and medical, where we've got over 40 years of developing solutions with these materials. But we don't just make the polymers. We also produce a range of semi-finished and finished products, including composite tapes, laminates, and overmolded components, as well as films, fibers, gears, pipes, and medical devices. To my role as Chief Scientist at Victrex, I have a broad scientific remit, principally covering chemistry and materials science, but also increasingly data science, modeling, and simulation. Part of my role is to develop and deliver our strategic research interests and capabilities. Our activities in composites across multiple markets is an example of that. Additive manufacture is another. So I work as part of the wider Victrex team with customers, with end users, with academic partners, to generate and deploy the science which supports finding those solutions that meet our customers' needs.
Well, when we talk about injection overmolding, research related to the COMPETE project, what did you contribute and what did you learn?
So I think what we contributed was our experience in the PEEK and polyarylether ketone-based materials, particularly formulating and processing them. we supplied the materials which facilitated the overmolding process. So on the one hand, there was the new low melting PAEK, which was used in Torres C-Tech fabric. And on the other, there was the high modulus injection molding compound, Victrex Peak 90 HMF40. And I think working with the TPRC was a great opportunity for us to learn and to accelerate the overmolding process development and background understanding. And as Sebastian and Franco mentioned earlier, I think I found the TPRC's hands-on experience being used alongside the modelling and simulation approach to be a particularly powerful and effective combination. And in addition to that, of course, we gained access to and generated a wide range of data on material and process parameters. And of course, that helped us build up the guidelines for the overmolding process that we have today.
Nice. And you already talked a little bit about this, these benefits. Later on, you became a complete TPRC partner. Can you explain a little bit more about the benefits for your organization?
Yes, so I mean, our experience in the first part of the Complete project convinced us that it would be valuable to become a Tier 1 member of the TPRC. And as I alluded to a moment ago, access to expertise that we didn't have within Victrex was clearly a key factor. But perhaps most important was that with the TPRC, it enabled us to collaborate with the entire supply chain at once, you know, from the equipment and machinery manufacturers through to the component and system producers, all the way to the end user. And without the TPRC membership, these interactions may have been a lot more sequential or very much more limited, and that would have limited the pace of technology development and the adoption of this new technology in the marketplace. However, when we work as part of the TPRC consortium, we're all focused on a series of agreed common projects and goals. And that means we can work on things in parallel across that supply chain, so the feedback loops are shorter, the communication's clearer, and the iterations faster.
Well, thank you very much, John, for sharing this story.